Hello all. So in the last few sessions we were discussing about sequential labeling and the two important tasks of sequential labeling, which are POS tagging and NER. So today in this session I would like to discuss about another important topic of NLP, which is modeling a language. Okay, so this is one of the most important topics in NLP for getting accurate results. Okay, let's see what is NER. So when I talk about language modeling, it is basically the most important or the basic fundamental task in NLP that involves predicting the probability distribution of the next word in the sequence of words. For example, if I take a sentence and I would like to predict the next word in the given sentence, I may have so many words which are suitable as the predicted word. Okay, but which word is exactly suitable in the given sentence is a question mark, right? So if I take a sentence called I didn't like the beach today because of dash. Okay, so there may be so many words that might be fitting in that particular prediction. For example, I say bad weather. I didn't like the beach today because of bad weather, or because of the people around the beach, or because of the food at the beach, because of the dogs at the beach. There are so many words that may be fitting properly into that particular prediction or the gap. So as humans, it sometimes would be confusing for us to understand which word exactly fit into the context. When we talk about machine understanding that and predicting the word, it is still a difficult task. So language modeling helps us to understand how does the machine solve this particular task. So here in language modeling, the machine tries to predict the probability of occurrence of each word. So the higher the probability, the more sense the word makes in the context. Okay, so basically language modeling is all about predicting the probability distribution of the next word in the given sequence of words. Okay, so that is the reason to exactly understand what is the context and then which word fits perfectly in that particular sentence. We use language modeling, and hence we say it is crucial component in many NLP applications such as machine translation, speech recognition, text generation, etc. Okay, so when I talk about language model, okay, so it is a statistical model that gives the probability to a piece of text. Okay, it is a statistical model that gives the probability to a piece of text. Okay, so an English language model would assign higher probabilities to sentences that look like English. Okay, so as I told you, we have so many applications of language modeling across various NLP tasks such as machine translation, where we use language models to predict target language words. Okay, and then when I talk about speech recognition, for example, okay, let me give you one example of machine translation here. If suppose I want to convert one sentence in French to English, okay, so let's say I have 3 words in French wherein I want to convert that into English, and what I found here is the third word that I've taken in French has multiple meanings. Okay, so in that case, which meaning would exactly fit into the sentence will be difficult to understand. So our language model will predict the probability of different words that we get, and the word with highest probability would be chosen when we are translating the language. Okay, so in case of speech recognition, language models will help in predicting the most likely sequence of words given an input audio signal. Okay, for example, I say you are right. I say you are right. Okay, this you are right may have RIGHT, WRITE, because the pronunciation is same here, or you are right maybe you are right. Okay, so multiple meanings and various combinations of this. So which one would exactly fit will be decided based on the probability. Okay, text generation, wherein we use language models to generate human like text for creative writing, to generate dialogues and all that stuff. Okay, when I talk about spell checking and correction, also these language models will assist in detecting and correcting the spelling errors, like how Word document, Microsoft Word does it. Okay, so it predicts the most likely correct word in the given context, right? So when you click on, if suppose I make a spelling mistake in the Word document, I get multiple probabilities of, when I right click on that, I get multiple options of which word would be correct. The word with highest probability would be given in the beginning, which we actually choose to correct Okay, so why are these language models useful? Okay, so when we consider machine language systems, machine translation, okay, we try to generate one sentence in one language into another sentence of another language. Okay, if you want to get high quality language models, so as I told you, Google translation systems were not that accurate some years ago compared to what Google translation systems, GMTs, that we use now. This is because of the language models coming into picture. Okay, as I've given you some example, let's take the Spanish sentence. Okay, here the third word has different meanings. Okay, several English equivalents which says strong, sharp, loud, heavy, and so on. Okay, so when I convert this particular sentence from Spanish to English, it says it is raining hard. Okay, hard is the word chosen because there are multiple equivalents to this word like strong, sharp, loud, heavy, but hard is chosen because that was most appropriate in the given context, and that I found out by using language models where it predict the probability of each and every word. Okay, now when we talk about speech recognition, as I discussed, which is also another task that generates text from given spoken audio input. Okay, so when I talk about speech recognition, the input would be an audio signal and the output would be the text which is generated. Okay, now when somebody utters the word you are right, okay, so how would a speech recognition systems know what exactly they mean by you are right? Okay, because when I talk about this first word you are, okay, so it may be you are or your, pronunciation is same, almost similar, right? So you have the same pronunciation, and when you talk about the second word right also, it can be RIGHT, it can be WRIGHT, it can be RITE, it can also be WRITE, because when I pronounce right, all these four words are pronounced in the same way. So which right is actually correct and used in the context? So this ambiguity is also resolved by using language model. Okay, so basically an English language model would properly re-rank these different attributes that are generated and identify what is the exact meaning and what is the exact word that is suitable for the given context. Okay, so how do we build these language models? Okay, so to build a language model, we have to take the simple RNN based sequential labeling task that we have done, but with some changes. Okay, so when we have, I hope you remember our skipgram model that we have discussed in the beginning of unit 1. Okay, so what does skipgram model do? It will predict the words in the context given the target word, right? One target word would be given and it will predict the different words in the given context, right? So here also we are doing the same thing, right? In case of language model also we are doing the same thing. So the similarity here is both the models. Which models am I talking about? The language model and also the skipgram model. So both the models predict the probability over possible words, right? So the difference here would be, when I talk about skipgram model, the input there is just a single word, whereas when I talk about language model, the input here is a partial sequence. Got it? So we can use the similar mechanism of what we have used for skipgram model to convert one vector into another linear layer, and then we convert that into probability distribution using softmax. So this is a simple architecture of a language model. Okay, as you can see, I start taking the words, I take the LSTM, you can go for simple RNN, you can go for LSTM, you can go for GRU, any type of recurrent neural network, and then we add linear layers. Along with that we add the softmax activation function with which we can predict the possibility of word, probability of the word and its occurrence. Okay, so the way RNN based language models are trained earlier is similar to that of sequential labeling modeling also. Okay, so there the loss function was sequential cross entropy, and here we use cross entropy loss, which is computed per word and averaged over all the words in the sentence. Okay, so this is all about language models. What is language model? How do we build a language model, and what is the use of language model for accurate translations? When I go for language, Google language translation, or for speech recognition, if you want to improve the results, we will add where the prediction are multiple in numbers, predicted words or sentences are multiple in number, and where the ambiguity occurs. We use this language model which clears the ambiguity and gives the correct prediction based on the probability of its occurrence. Thank you.